Hello everyone. Today we're going to have a little longer of a lab than usual, but this one should be pretty fun and insightful. As you can see here, we have a list of instructions via this project we're going to attempt in our lab today. So the first thing we need to do is remove any existing static routes. We need to activate any disabled interfaces. We need to implement OSPF, Open Shortest Path First, on all routers, Process ID 1 on all. Process ID is just specific to the router. Configure router IDs as per the topology diagram. We need to ID each router so we can accurately locate in the command line which router is doing what as per neighborship in the database, LSA database. Confirm connectivity using ping tests. We're going to use simulation tools to analyze the OSPF path selection. We'll verify OSPF database for complete route information. We'll check the routing table for the OSPF routes using the show command show IP route. And we'll confirm OSPF neighborship via show IP OSPF neighbor command. All right, well, let's go ahead and jump in. All right, so as we can see here, this is our topology. We have 5 routers. They have been configured with static IP addresses. So the first thing we need to do is we need to do some troubleshooting to figure out why this interface is down. We also need to go in and remove the static configurations, the static IP addresses, so we can implement OSPF, which is a dynamic routing protocol. Pretty cool stuff. So yeah, okay, let's jump in. So first thing we need to do here is let's just start here on router 0, I guess. So enable CompT. Let's do a do show IP interface brief. This is just going to quickly show us the interfaces that are tied to this router and their state. We can see the IP addresses that have been allocated to this router. G000 interface 10.1 and 40.1 on the G001 interface. They're both up, so we look good there. So we don't have any issues on this router. Let's move over here to this router. Let's do the same check. Enable, configure terminal. Let's do a do show IP route, or actually IP interface brief. And here we can see the routing configurations for this router. We can see the interfaces are tied with IP addresses 40.2 and 50.2. So we can see 50.2 and 40.2 going down here. And let's see, it looks like we have 40.2 is down. So this is the interface that's down, of course, and it's on this side of the interface. So let's go in and correct that while we're here. So let's do a interface G000. Let's do a no shut command. It's going to bring the interface up, which it did. So now we have a complete link, which is good. So now let's jump in and go. All right, since we're here, let's start configure or locating static routes and removing them so we can implement OSPF. All right, so let's do a do show IP route. This is going to bring up the routing table for the router. It's going to show us the IP addresses that have been allocated. As you can see here, we have a couple of static routes. So we need to get rid of these addresses here. So what we're going to do is we're going to use the command no IP route. And we're going to get rid of this IP address right here. This route here, if you will, this static route. So no IP route 192.168.0.0, 255.255.0.0 being a /16 subnet mask. And then we're going to go in and do a 192.168.50.1. And then we can also go in and do the 40.1. So let's go ahead and do another do show IP route. And as you can see, we've cleaned up the static routes off that router. So good. So now, since we're here on this router, let's just go ahead and enable OSPF. So the way to do that would be router OSPF, 1, process ID of 1, and then we're going to go in and do a router ID. Router ID appears to be 4.4.4.4, which makes sense because our router number is 4. And then we're going to allocate the IP addresses that we want to add to the OSPF database. So it looks like we're going to be adding in 192.168.40.0, okay, for the network. And then we're also going to be adding a wildcard mask, which is the inverted subnet mask, 0.0.0.255 area. Let's just call this area 0. Okay, so now we're going to do the other IP address, which is the 50.2. All right, and that should be it on this router. So let's jump over to this router over here. We'll go to router 0. And let's do a do show IP interface brief. Okay, and now let's go to a do show IP route. And we can see we have a couple of static routes here. We got 2 there, and we got 1 here. So let's go ahead and get rid of these. So no IP route. 192.168.30.0, 255, 255, 255.0. It's a /24 subnet mask. And then as you can see here with the /24 notation, and then we're going to do the 192.168, 10.2. And then it looks like we can do the same thing, but for the 30, we can do 20. And then let's see, so that'll take care of those 2 at the top. And then we have 1 more down here at the bottom. So let's do a no IP route, 192.168, 50.0 /24 subnet mask, so 255, 255, 255.0. And then we're going to do the 192.168.10.2. And then we'll do the 40.2 as well. So let's do a do show IP route. And we can confirm that we no longer have any static IP addresses here, only local and connected networks here. Okay, so let's move over here to router 1. Enable, COMP-T. Let's do a do show IP interface brief. No, we already verified all interfaces, so let's just do a do show IP route. Okay, got a couple here it looks like, or 1 up here. So let's do a no IP route, 192.168.0.0. It's a /16, so it's only going to be a 255.255.0.0 subnet mask. And then we're going to do a 192.168.10.1. And then we'll jump to a 20.2. Let's do a do show IP route. And we are all clear. So let's jump over to router 2. Enable, COMP-T, do show IP interface brief. Okay, we're up and up. 20 and 30, 30, 20 look good. Okay, so now we can go do show IP route. And we got some statics up here it looks like. So let's go ahead and get rid of them. So no IP route. 192.168.0.0, 255.255.0.0, and then because it's /16, so 816. So then we're going to go 192.168, 20.1. Then we can do 30.2. Okay, and then it looks like also we can do 10.0. /24. Let's just do it this way. Okay, they're all gone. Good. Let's jump over here to router 3. Enable conf t, do show IP route. Okay, we got this guy here, and we got a couple up here. So let's do a no IP route. 192.168, 40.0, 255, 255, 255.0. 192.168, 30.1. And then it looks like we can do .2. And we can also do 10.0, which is tied to the 30.1. And then we can do 20. And then did we do, yes, we did do the 40 already, so we should be good now. So do show IP route, and we're clear. Okay. And okay, so we already did the router OSPF on this one. So okay, so let's move on. Let's go down here. Let's do router OSPF1. Let's do a router ID of 5.5.5.5. Let's do the network 192.168.40.1. Actually 40.0, 0.0.0.255. Area 0. Let's add another O in there. Okay, let's do another one. Net, we're going to do the 10.1. So net 192.168, 10.0, 0.0.0.255, area. Okay. Let's give that a minute. So that should be 40 and 10. Okay, good, good. Let's jump onto this guy, do the same thing. Router OSPF1, router ID 1.1.1.1, network 192.168.10.0, 0.0.0.255, area 0, net 192.168.20.0, okay, let's give that a second for the routers to exchange LSAs and to update themselves. Basically saying hello to each other. I'm here. Okay. Let's move on to the other router here. Let's do router OSPF1. Enable it. Router ID 2.2.2.2. It is attached to the 192.168.20.0 network. 0.0.0.255, area 0. Let's also do the 30 network. Okay. Now let's jump over to this guy. Same thing. Router OSPF. Router ID 3.3.3.3. Network 192.168.30.0, 0.0.0.255, area 0. And we're going to add the 50 this time. Okay. There we go. And let's jump over to this guy real quick. We already added. Okay, good. Okay. So we should be done now with the OSPF configuration. So let's go ahead and let's test it. So let's do enable. Let's do a ping. So we're on router 4 right now. So let's go ahead and ping, I don't know, let's ping router 2. Right here in the middle here. So we got to go one hop through to get to him. So let's ping 192.168.30.1. And it works. So let's go ahead and ping, we'll ping this guy just to test him as well. Ping 192.168.20.1. No, let's do 10.2. Let's do this side. So we went both ways. Okay, very cool, very cool. Let's test this guy real quick. Let's ping, I don't know, let's ping, I guess we'll just ping router 3. So ping 192.168.30.2. Okay, very good. So we have full continuity across the topology here. So as you can see, we dynamically allocated routes via OSPF. The cool thing is that these routers are now talking to each other. So if any changes in the network, let's say an interface goes down, they can adjust, they can make changes on the fly to keep the network up and running. And in the event of a failure or an outage, they can reroute packets another direction, another route to establish the connection. And you know what? Let's go ahead and let's practice that. Let me show you what that looks like here real quick. So let's see. We're going to let's go ahead and shut down. Let's see if we want to block. All right, so we want to be able to get to router 2. But what we're going to do though is we're going to bring down this interface. So let's just assume, I don't know, somebody unplugged a cable broke, whatever the situation. Let's do this. Let's do interface G00. Let's go ahead and shut it down. As you can see, we just killed that line. It's offline. And now we're going to try to ping router 2 from router 1. Okay, so let's do this. Okay, and as you can see, it was successful. But let's go over here. Packet Trace has got this really cool option. It's called simulation mode. So let's see how we can do this. Okay, so we'll go ahead and reissue that ping command, ICMP, which is a protocol that's going to test not only the direction there, but the direction back. So it has to work both ways. It's an echo request. So are you ready? We're going to run it now. And you can see now the packet gets sent to router 4. It's going to get sent to router 3. So it's completely inverting the down interface while still delivering the packet to the destination. Okay, pretty cool stuff, huh? And then you see as the echo request, it's going to go there and then it's going to come back. So it's going to let it know that not only did it reach it, but that it can reach its way back to the source. So it's reached its destination and then it's going to return to the source. Okay. So now let's go ahead and do this real quick. Let's do so let's go back to router 1 here. Let's bring that interface back up. And I just want to show you something here. It's pretty cool. So we'll do router 1 or router 0. We'll do the same test again, but we're going to do I'm going to show you the okay. So it found its shortest path to go around. And that could be because, well, no, they're all gigabit Ethernet interfaces, so bandwidth and delay. But you can see now it's delivering the packets, which is pretty cool. So let's do this then. Let's ping a different interface now. Let's ping router 3. So we'll do router 3, which would be .30.2. Okay, it was successful. Let's go ahead and do it again. This time I can show you what it looks like. Okay. Pretty cool. All right. So what I want to do now is we saw the route went this way, but I'm going to shut this interface down right here now on router 4. So let's do okay. So we just cut him off from his route. Let's see how he adjusts to this new route. Oh, look at that. So he knows automatically to go a different way. Pretty cool stuff, huh? Yeah, so it's made changes dynamically on the fly, no admin or manual interruption to make that happen. Um, it's made itself as efficient as possible. So let's go ahead and let's bring our interface back up. Okay, it's back online. Very good. Okay, and so we've confirmed connectivity using ping. We've configured the router as per the topology diagram. We implemented OSPF on all routers, process ID 1 on all. We activated all disabled interfaces. We removed static routes. We used the simulation tool to analyze the OSPF path selection when we interrupted the paths by shutting down the interfaces. And as you can see here now that OSPF has just reloaded the interface because now it's brought back online. So the routers are now talking to each other. So now let's do, let's see. So now it wants us to verify the OSPF database for complete route information. So let's go to compt do show IP OSPF database. So here, this is pretty cool stuff. So you can see here that we have our connections, what routers provided on what interfaces and what IP addresses are tied to them. And so this is essentially, these are the connections made, the neighborships made between the routers. These are updated, I believe, every 10 seconds, so they know where they're at all times. I believe it's 40 seconds if they don't hear from a neighbor before it will drop or close the connection and will reroute. So these guys are constantly talking to each other, which is really cool stuff. Let's do one more command real quick, another show command. So let's do a do show IP OSPF neighbor. And so here we can see that there is a full establishment, neighborship's been created, so they're in the full mode of communication back and forth. And we have border designated routers. And let's see if we can find the actual designated router. Let's see, so we're in router 0. Let's go over here and see if we can find. So that's the backup designated router. Let's see if we can find the designated router, the big boy that's actually in charge of updating LSA information. So let's go over here to router 1. Let's do a do show IP OSPF neighbor. And there we are. So you can see we have the backup designated router is number 2 in line, and then we have a designated router, which is number 1 in line. So he is the big boy that is providing all of the updated information. And let's see, so I believe that covers everything for this lab today. I appreciate your time. Thank you for joining and viewing, and we'll see you next time.